All right, Saxon Algebra 1, we are jumping into our lesson 56, and it is page 228 for those of you guys who have your books out. All right, so page 228. And I do want to encourage you guys to make sure that you take time to read over. On page 228, there's a whole lot of boldface terms, and that's really important that you take time to read over those and understand what those terms are. Some terms we might think, well, just my Saxon book does that. But the reality is that it's not just Saxon, because you might have a college class someday, or you might have another high school class, and that class is going to have terms that you need to understand and know what it's discussing there. So it's talking about finite and infinite sets. So a set with a finite number of members is called a finite set. So that means that it has a specific amount, right? Now, if it has an infinite number, you're going to see the ... right? That means it keeps going. It doesn't stop. That's infinite. Think about us as humans. God is infinite. He doesn't have a beginning. He doesn't have an end, but we do. We have a set, right? There's exactly, if you walk in a cemetery, you see a beginning and an end for people, right? But that's not just an infinitely amazing God that we serve, right? He has no boundaries, no limits. So just think of it that way. Finite, as humans, we have boundaries, right? But infinite, meaning never ending. It can before or after, all right? So your book explains that on page 228. Then at the bottom of page 228, it talks about numbers in a set. So if we have the following numbers, it shows how many zeros, how many ones, and how many twos. There's tons of them, aren't there? But if we wish to designate those in a set, the only numbers in that set are 0, 1, and 2. Now, there's multiple of them, so that would affect our average, right, or our median, just because there's more than 3 numbers, but there's only 3 types, right? So note that each of the numbers is listed only once when we're naming what's in the set, okay? So it says, represent the following numbers as being members of set K. So what they did is they just listed the numbers one time and then put them in order. So even though there are more than that. All right, so your book kind of shows that. Then on page 229, it shows some symbols that your book will use. We list each number only once, and we use the symbols to designate a particular symbol or number is a member of a given set or not. So 0 is part of the set L, or 23 is not part of set L. So it's important for you guys to know those symbols and what they mean, especially if you see that in your homework and think, what in the world is that, right? So understand how that is. Now, one thing that your book that's super important, sometimes we can, have y'all ever saw something where it has like terms and you think, this is a term, I don't really need it. It's super important that you guys understand that when it's giving you those terms, you're going to see those terms again. So that's really important to kind of know and understand. Now, 56C is super important. I love graphing in Algebra 1. And if you talk to students who have had me before, they'll probably tell you how much I'll tell you. This is your best friend formula. So it's super important that you guys know that graphing and isolating y on the bottom of page 229, this is the beginning stepping stones for some of the most important things we're going to go over, core truths that we're studying in Algebra 1. So I know that you don't realize how important this is, but I hope that you guys really take time to understand this is important. So look on page 229, it says graph 3x plus 2y equals 4. Now you have not, that format is what we call standard form. It has x and y on both the same side of the equation. And you've not graphed that before because you've made a chart, like at the bottom of this, you've made a chart and plugged in if x is 0, what's y? If x is -1, what's y? If x is 1, what's y? So you've done these charts. Well, what you're having to do is isolate the y. So your book shows you, take that equation and move everything else to the other side of the equal sign, but get y by itself and then solve. So that's super important. And again, that's on the bottom of page 229. And that would be isolating your y. You need to get y by itself. And so then if you turn to page 230, it shows getting y by itself and then graphing it. It's a beautiful straight line. They've picked 3 points, and then they drew a straight line through those points. All right, look on the bottom of page 230. They did another equation, this time graphing. It was just y minus x equals 0. Well, I've still got to get y by itself. So what did we do? We added x to both sides. So y equals x. No matter what y is, it equals x. So they just picked 3 different numbers, 0, 3, and -3. So when x is 0, y is 0. When x is 3, y is 3. When x is -3, y is -3. So they graph that. So do you see that there? So that's this one right here. And what your book is showing you is that it is a it is a line. It's actually a positive slope because it's rising, right? But they put in the 3 points and then drew a straight line through it. So you guys, this is a super important lesson because this is a stepping stone of basic graphing that we're going to be doing, okay? Now let's look at our practice and make sure you're taking notes on this because this is super important this week that we take our notes. So practice A, represent the following numbers as being members of set K. So I'm looking at my letters and trying to decide what comes first. So let's look at that. So set K. So the members of set K, and your book kind of has like a little, I don't know, it kind of looks like an E, doesn't it? The members of set K are 0. Now, we should put them in order. There are 2 zeros, but I don't have to write it twice because we're just listing the members. Even though there are 2 zeros, it's still 0, 1, 3, 5, and 9. 0, 1, 3, 5, and 9. Sorry, that 3 looks a little wonky there, doesn't it? All right, 0, 1, 3, 5, and 9. All right, so that is set K, and it includes all of those, right? Okay, given that set A equals 0 and 2, and B equals 0, 1, 5, 6, and C equals 1, 3, 4, 6, are the following statements true? So all we're doing is looking at these and seeing, are they true? So it says that 5 belongs to set B. So is 5 in set B? Yes or no? Yes, 5 is part of set B. Now it says 5 is not part of C, and that's true as well. 5 is in B, but not in C. So that's true. So that's all that you're doing in that lesson is just understanding that when it has this, it means it belongs to the set. When it has a line through it, if it goes like, excuse me, I put my finger through it, but you guys understand. If it has a line through it, it means it does not belong in that set, right? Maybe you've seen signs for like no texting somewhere, and they'll have a cell phone and they'll put a line through it. Or no smoking somewhere, they'll put a line through it. That's all that the set with a line through it means it's not part of that set. All right, now letter C is super important, and we need to understand what we're doing there. It says 2x minus 3y equals 6. So it's asking us to graph that, okay? Now, remember that this is standard form, and we'll talk more about standard form the further we go into algebra. But you have to isolate the y. So if I'm isolating y, I'm going to move over the x. So that would be minus 2x to both sides. Now that's going to leave me with negative 3y equals negative 2x plus 6. Now I have not isolated y yet by itself because I've got to get rid of the negative 3. So I'm going to divide through by negative 3. So I end up with y equals positive 2/3. How come? Because I've got a negative and a negative. That makes positive 2/3 x. And then I've got positive 6 divided by negative 3 would be negative 2. All right? So now, your book says graph it on a rectangular coordinate system. So what I have to do is I have to pick a few numbers. Your book does it horizontal. I like to do it vertical. But let's plug in if x is 0. If x is 0, 2/3 times 0 is 0. 0 minus 2 is negative 2. All right, now let's pick another number. Let's do negative 3, and the reason I'm doing that is the fraction I want it to cancel out. So if I have 2/3 times negative 3 minus 2. So y equals, I'm just substituting in negative 2/3. So 3 and 3 would cancel out, and it would end up y equals negative 2 minus 2, so y equals negative 4. So I'm going to write that here. All right, and now I need to do one more point, so I've got 0 and 3. Let's do positive 3. You actually only need 2 points to make a line, but I think it's always a good practice to have a third just to make sure you're in the right direction. All right, this time we're going to say y equals 2/3 times positive 3 minus 2. So the 3's cancel out and leave me with y equals 2 minus 2, which would be 0. So at 3, it's 0. Now we need to graph that, and unfortunately I've ran out of board room, so I'm actually going to just erase where I just did the work for these points, but hopefully you have that on your paper, right? So I need to graph this. So the highest I'm going is negative 4. So that's negative 4, negative 4, that's positive 4, and that's positive 4. So I've got my x-axis and my y-axis. So let's take a look. If it's 0, negative 2, that means it doesn't go right or left, and negative 2 comes down. Negative 3, negative 4 is here. And then I've got 3, 0. That means it goes to the right 3, but doesn't go up or down. So friends, I've got this line. Now at home, on your paper, I would encourage you to use a straight edge, the side of a book, something that's straight to make sure your line is straight. It's easy to miss it and then you go crooked. Sometimes I'll tease and say, well, my board went crooked, but it's really me, right? So try to use a straight edge. But this graph is this equation that we started out with. All we had to do is get y by itself, and then we just had to substitute in. We're kind of isolating the y, and then we're just plugging in variables. If x is this, then what's the y? So remember that depending on what x is, we can figure out what y is. And this line continues this direction or this direction. All right? So that is lesson 56, and you're going to be doing a lot more with graphing, so it's important that you guys learn this. I'm actually going to show you on graphing calculators how we can plug that in. You can plug this part in to a graphing calculator, and up will pop this. Then you can press second graph, and there's a table, and the table will actually show you these points. So we'll look at that a little bit more. If you have a TI 83 or 84 plus Silver Edition, those are some of my favorites because they've got some shortcuts in them. But if you don't have a graphing calculator, that's okay. You can use, they've got free apps on cell phones or on computers, but I would encourage you guys to take a look at those, okay? All right, lesson 57 talks about addition of algebraic expressions with negative exponents. So how do I add those together? Well, this lesson is actually really short on lesson 57, and it just shows you when we simplify this, whatever the negative is, it moves to the denominator, then you've got to get a common denominator. And that's nothing different than what you've had before. It's just that they start out looking different. So hopefully this is nothing that will intimidate you, even though it's a new looking concept. It's just another way that it starts out different, but then you've already handled them, so hopefully that won't be too intimidating. So let's look at practice A. Practice A is ax negative 1 minus by negative 2. All right. So what is that? All right. If I rewrite it, it's a over x. Because this is the only negative, it becomes to the denominator. Minus b doesn't have a negative exponent, just the y negative 2. So this is the only part that moves down, y squared. So that's actually rewritten what it looks like. A over x minus b over y squared. So it looks different, but you guys know that I need a common denominator with that. So my new denominator is going to be xy squared minus xy squared. So now I've got a common denominator, and I have to decide what I multiplied each one by. Well, I multiplied each one by x squared for the first, so it would be y squared, not x squared, y squared. Then here, the only thing that's missing is x, so it would be bx. So now my denominators are the same. Bring it over. And then it would be ay squared minus bx. And there's nothing in common that I can reduce. The top is a binomial, the bottom is a monomial, so I can't mark anything out. So this is my final answer, and I am finished. Okay? So that's the only one I'm going to do in lesson 57. So again, you've done that math before, you've just not started it that way. So all they're having you do is understand a negative exponent, you just flip it to the opposite side. If it's in the numerator, flip it to the denominator. If it's in the denominator, flip it to the numerator. Then just get a common denominator, okay? Now, lesson 58, you can do it one of two ways. I love Saxon, and I love the way that they show you visually. And if you'll take a look, they show you pictures of, okay, this is my whole, this is the part that I have of the whole. And each of us are able to visualize things a little bit differently. For me, I like to just rewrite it in a math sentence. Instead of working it out and doing it that mathematical way, I'd rather just rewrite it in an algebraic sentence. So you guys are welcome to read over page 235 at the bottom, and then all of page 236, and they show you how to set up those ratios. Now, I've been teaching algebra for a long time, and as a teacher, one thing I've noticed is sometimes students can very easily confuse their ratios, and if you put it in the wrong order, even if you have the right numbers, if it's not set up where the means multiply out to equal the extremes, you can get the wrong answer. So it's super important that you take time to set those up properly. So I've seen a lot of students who just missed it by setting it up wrong. And so that kind of breaks my heart. So I like to set it up a little bit differently. So I like to just rewrite it in an algebraic sentence. So your book shows you like 100%, and then 600 is 160%, and then to solve those. So sometimes you just have to come up with a new sentence to write it that way. All right, look at page 237. And again, you can do it the Saxon way, or I just rewrite it in a math sentence. All right. Jane and Faye have 32 bagatelles, I don't know, but they have something. They have 32, we'll just say bags. That'll be a lot easier, right? So Jane and Faye have 32 bags left. If they began with 160 bags, what percent of the original number remains? All right, so they have 32 left. So what percent of the original? So that's what's super important. So we need to think through, how can I write that in a math sentence? So if I can think through a math sentence, how to write that, all right? So they have 32 left, and it says what percent of the original number remains. So I have 32 is what percent of 160? So let's think through, is that what they're asking me? It says what percent of the original number, and it told me they began with 160. So as long as I rewrite this in an accurate math sentence, then I can solve it. It says what percent of the original number remains. I have 32 that remains, and I know this was the original. So this is the right sentence. 32 is what percent of 160. Now, friends, all I have to do is rewrite that in an algebraic statement. 32 Is means equals. What percent? Let's write X percent. Of means multiply, and then 160. Do you see how so many times we can just get panicky with these statements and then think, should I multiply, should I divide? And I feel like I've had a lot of students that they just pick a daisy and say, what should I do, what should I do? And they just grab some numbers and either multiply and divide it and hope it turns out right? But as long as you start out with an accurate statement, mathematically, it will tell you what to do, right? So 32 is X percent of 160. So all I've got to do is get the variable by itself. Inverse operation of multiply is divide by 160. So X percent equals 32 divided by 160. Now, all I have to do is reduce that. I know that 4 goes into both, 8, and then that would be 40, and then that reduces to 1/5. So 1/5 equals X. I need a percent. So I know if I divide that in, or hopefully you guys know your some of your fractions, or your fractions, decimal, and percent come back to mind. So 1/5 equals 20%. And if you're not sure of that, you can take your calculator and say 1 divided by 5, and that's 0.2. So if X equals 0.2, I just move it over 2 places, which is 20%. All right? So you're going to be doing that for that section. And again, all you need to do is just rewrite it in a math sentence. Now, if you like the Saxon way of actually writing out and showing what part of a whole, that's totally fine. All right, the last lesson that we're going to go over is lesson 59. And last week we talked about substitution, and I told you all that they had isolated it for you. But ta-da! This week, do you know what? You have to isolate one of the variables. So you have to choose which one is the easiest to isolate, to get by itself so that you can substitute. So friends, you're not learning anything new this week. All you're having to do is think through, how can I get one of these variables by itself so that I can substitute? Okay, so let's take a look. The book has given you to practice on our last lesson, which is lesson 59. So everybody, let's look at A and B. Let's do both of those on this practice because I think it's super important. Okay? So again, we're on lesson 59, the last of our lesson this week, and we're learning how to isolate and to substitute. We've already learned how to substitute, but this new step is we're isolating. So X minus 3Y equals -7, and then 2X minus 3Y equals 4. So I've got two equations. And remember we talked about last week that when I'm graphing, I'm looking for where two lines cross, and I need that solution is an ordered pair, an X and a Y, where those two lines cross each other, where the only point that they share, an X and a Y. So both of these are what we call standard form because the X and the Y are on the same side. So in order to solve it, I need to isolate one variable. The only one that has no leading coefficient is the first one, X. So that's the easiest one to isolate. So what I'm going to do is I'm going to add 3Y to both sides. So now I have X equals 3Y minus 7. Do you see what I did there? I just moved the negative 3Y to the other side by adding 3Y. So now I have isolated X. So if X equals this, let's substitute it in the next equation, right? It'd be like if I'm out, you guys would get a substitute teacher. So the substitute teacher's value is the same as mine. She's replacing me for that time period. So 2, instead of X, I'm going to plug in 3Y minus 7 minus 3Y equals 4. So everybody see that? I isolated X. I isolated one variable. I substituted that in for the X in the second equation. Now I'm going to distribute because there was a coefficient in front of that X. So it's 6Y minus 14 minus 3Y equals 4. Now, both of these are on the same side. I have 6Y, I owe 3Y, so I have 3Y. Now I'm going to add 14 to both sides to move the numbers to the same side. So 3Y equals, oh, I said 28. I'm sorry, friends. 3y equals 18, doesn't it? So I had 4, and then because I distributed there, I'm going to add 14, all right? So that would be 18. So I'm going to divide 3 by both sides to get y by itself. So when I get y by itself, y equals 6. Now here's the key is a lot of students would say, okay, I'm done. I got y by itself. But we're not. Remember, I need an ordered pair. I need to know an x and a y. So if y is 6, I'm going to plug it in over here. 3 times 6 is 18. 18 minus 7, x equals 11. So if x equals 11, let's write it as an ordered pair. 11, 6. And that is my final answer. I found out, I isolated one variable, I substituted that in and got it down to one variable, then plugged that back in where I isolated it, and I got my x and my y. All right, let's do it one more time. Let's take a look at letter B. All right, so that was letter A. Let's take a look at letter B. All right, and again, this is the last lesson, lesson 59, letter B. I've got 4x minus y equals 41, and then 2x plus y equals 25. Now you can choose which one that you would like to solve for, but I'm going to choose this y because it's positive. So I'm just going to subtract 2x, and I'm going to have y equals negative 2x plus 25. I've isolated this y, and I'm going to plug this in for the y up here. Now here's the tricky part. There's a negative in front of that y. So notice that I'm plugging in this value, negative 2x plus 25. So friends, it's super important that you watch your signs, all right? So negative 2x plus 25 goes in for that y, but don't forget there's a negative in front of it. So that negative has to be distributed or multiplied to all. So I've got 4x minus a minus makes plus 2x, but don't forget that minus goes here too, and that's where I see the biggest mistake, is people forget to make it go to both, all right? So be on the lookout for that, equals 41. Now, 4x plus 2x makes 6x, but I'm going to add 25, so I end up with 6x equals 66. Divide both sides by 6, x equals 11. I feel like the last one we had an 11, didn't we? So if x equals 11, let's plug it in here. Negative 2 times 11 plus 25 is y. So y equals negative 22 plus 25, so y equals 3. So my answer, 11, 3. And that, my friends, is an ordered pair. Okay? All right. I hope that that's an encouragement to you guys. And a lot of it is not new. It's just taking some familiar things and adding it to it. Great job.